Hi and welcome to this video on speed, distance and time, maths made easy. When we talk about speed, we usually say it's in kilometers per hour or meters per second, and this is a way of remembering this formula triangle to remember the formula. So speed is distance divided by time. So distance is kilometers, time in hours, so that's speed. Distance divided by time gives us kilometers per hour. Distance divided by time, kilometers per hour. And then we can sort of from this formula triangle work out that distance is speed times time, and then time, distance divided by speed. When we're working on a question, always make sure that the units are the same throughout your working. So if you got kilometers per hour, don't mix this time with minutes, convert it to hours. And we usually like kilometers per hour. We can give the answer in meters per second, but kilometers per hour is better. So if we have 2.35 hours, this is not 2 hours and 35 minutes. 2.35 is a decimal, and you need to convert it into hours and minutes. So if we get the 0.35 and multiply by 60, the 60 minutes in 1 hour, we get 21 minutes. So 2.35 hours is actually 2 hours and 21 minutes. Okay, so it's 141 minutes. A car travels at 7 kilometers at 28 kilometers per hour. How many minutes does it take? So from our formula triangle here, we get that time equals distance divided by speed. We know the distance is 7 kilometers, and we know the speed is 28 kilometers per hour. So 7 divided by 28, 0.25 hours. So 0.25 is a decimal, and we want to convert that into minutes. So 0.25 times 60, 15 minutes. Speeds are made of two measures, distance and time, and we have to convert both separately. So we've got 48 kilometers per hour, and we want to make that into meters per second rather. So we've got 48 kilometers per hour. To make that into meters, we multiply by 1,000, so that makes it 48,000 meters per hour. So we never say anything meters per hour, or say meters per second. So then we have to convert the hours into seconds, so there's 3,600 seconds in an hour. So we divide and we get the answer. Alternately, this 1,000 that we had here, this unit that we multiply by 1,000, and this 3,600, we get 1,000 over 3,600, which is 5 over 18. So we can actually multiply this 48 by this factor, conversion factor of 5 over 18, to get kilometers per hour into meters per second. So 5 over 18 to convert it. And to do the opposite, to convert meters per second to kilometers per hour, we multiply by the reciprocal of that, which is 18 over 5. If a man covers a distance at x kilometers per hour and then the same distance at y kilometers per hour, then the average speed is given by this formula, which is 2x multiplied by y divided by x plus y kilometers per hour. Just going to go over some questions just to get us used to this formula. So a person travels a road 600 meters long in 5 minutes. What's his speed in kilometers per hour? So here we've got 600 meters and we've got 5 minutes, so we want that in seconds, so that's 5 times 60. So 600 divided by 5 times 60, we get to our answer as 2 meters per second. So meters, and this was in seconds. Now we want to convert this into kilometers per hour because that's our preferred units. So we get the meters converted to kilometer is 0.002. We divide by 1,000. Okay, and the seconds into hours we multiply by 3,600, and we get 7.2 kilometers per hour. A plane covers a distance at a speed of 240 kilometers an hour in 5 hours. To cover the same distance in 1 hour 20 minutes, what speed must it travel? So first of all, let's work out the distance that this plane has traveled. So it's traveled 240 kilometers an hour and it's traveled for 5 hours. So that's 240 times 5, 1,200 kilometers. That's the total distance it's traveled in 5 hours. Now speed from our formula triangle is distance divided by time. So we've got this distance 1,200 kilometers and we've got this time of 1.33 hours. Remember, convert the 20 minutes into a decimal. Okay, so 20 minutes is 0.33 of an hour. So 1 hour, 0.33, and we get 900 kilometers per hour. Don't divide by 1.2. You want to cover a distance of 15 kilometers in 2 hours 30 minutes. What speed must you travel? So this as a decimal is 2.5 hours. So distance is 15, so 15 divided by 2.5, 6 kilometers per hour. If we want the same, want to cover a distance of 17 kilometers in 20 minutes, so that'd be 17 divided by 1.3. 20 minutes, remember, is a third of an hour. So sorry, divide by 1/3. Okay, so we can do it that way. We can divide by a third. Or if we want to get the reciprocal of that, multiply by 3. So which is 51 kilometers per hour. Okay, so remember, dividing by a fraction is the same as multiplying by its reciprocal. A person travels 14 kilometers per hour instead of 10 kilometers per hour. So he's traveling here at a faster speed and he travels an extra 20 kilometers in the same time. What distance has been traveled? So we can do this by equating x over 10, which is the slower speed. So 10 kilometers per hour, x over 10, yeah. So distance over speed, and this distance will be x, this same distance plus 20, because they've done 20 kilometers more, divided by 14, which is the greater speed. And then cross multiplying, we get 14x equals 10x plus, don't forget to multiply this by 10, 200. And then when we bring this 10x over here, so that's 14x minus 10x is 4x equals 200. So x is 50 kilometers. Distance time graphs, very popular in questions because obviously it's a graph and they need to do working out and things like that, and working with these little sort of squares and counting. So first of all, this is a distance time graph, and in this we have the distance in meters as the vertical axis and the time along the horizontal axis. Now the gradient of this line is the speed that we're traveling. Here we've got a horizontal line, so we're stationary, we're stopped, we're not traveling. Here we're traveling again, the gradient is the speed. The slope, the gradient tells us what speed we're going, so here we're at a greater speed than here. Yep, because this is a gentler slope than this. And this is our return journey, where we were at 1,000 meters from the place we started, and then we're going back to where we started. So this gradient would be the speed at which we returned. So the gradient. We do not use the area under the graph where we have a distance time graph. This area under the graph comes from speed time graphs. So here we have the speed or the rate of change of something as our vertical axis and the time as our horizontal axis. The gradient is the acceleration. If you look at this graph, it's the same as the earlier one, okay, but here we've got speed against time, rate of change against time. So the gradient of this line would be the acceleration. This flat piece here is not where we're stationary. This is a steady speed, so we're going at 80 kilometers per hour for this length of time. Okay, from here to here we're still going at 80 kilometers per hour. Here we've got another acceleration, and this negative slope is a deceleration. Okay, and then the area under the graph is the distance traveled. So what we normally do is we split the area under the graph into rectangles and triangles, work out the area, and that's the distance, or the total distance traveled. Let's just go over some little pieces of that speed time graph. So if we've got a vertical line that shows a constant speed, we can use speed time graphs to find how far we've traveled, or how far something has traveled. And the distance is speed times time. So in this case, it'd be, this speed is a constant 80 meters per second for 40 seconds. So remember that speed is per second, which is s to the minus 1. When we multiply by s, remember our minus 1, when we're multiplying by 1, which is our power, we add, so we're just left with meters. So minus 1 plus 1 is 0, and we're just left with meters, yeah? So this gives us a distance. Another way to think about this is, that was 80 times 40, yeah? 80 times 40. And if we look at that, that's the area here under this line. So if we draw a dotted line to here to 40 and work out this area, this also gives us the distance. So the area under a speed time graph underneath our lines gives us the distance traveled. Okay. If we've got a line like this which has got a gradient on a speed time graph, this tells us that there's acceleration, and also the average speed can be used to calculate the distance traveled. So the average speed here is from 40 to 80 divided by 2, so that'll be 60 meters per second, and we multiply that by the time here, which is 30. So average speed times time is the distance traveled. 60 times 30, 1,800 meters. And like we said, the other way to do this, or if we're asked to do it, is to work out the area under that line. We do that by making a rectangle and a triangle. So the area of the rectangle is 30 times 40. The area of the triangle is half the base times the height, which is 15 multiplied by 40. So that's 1,200 plus 600, 1,800 meters. So it's the same as this. A positive gradient is an acceleration, so we're increasing in speed all the time, so we're accelerating. So if we work out for this, this is 60 meters per second, and we divide that by 40, so this gives us 1.5 meters per second as the acceleration. Okay, so we work out the gradient. So the gradient is the rise over the run, or this line, which is the y over the x. If we've got a negative gradient, this is a deceleration. Again, the gradient shows us that it's a deceleration. To work out the gradient, we've got 20 to 80 is 60 meters per second divided by 30, which is the time, and gives us minus, because this is a minus gradient, minus 2 meters per second per second.